All right, friends, we are live here. This is a live note session here from Sutton High School. Exciting stuff. 5.1 we're doing in the Larson Precalc book, and we are going to look into simplifying a trig expression. My tip of the day is if you see something that's squared, you should look back to your favorite three things: sine squared plus cosine squared equals 1. Right? And if you divide that through by sine squared, you'll get 1 plus cotangent squared equals, 1 over sine is cosecant squared. And if you divide this through by cosine squared, you'll get tangent squared plus 1 equals, and you're dividing by sine, so you'll get, whoops, did I mess that up? Darn. I think I almost did. No, I didn't. Okay, that's good. We're dividing by cosine squared, so that's going to be secant squared. So we're going to use one of these three. Which one? Do you see anything here on the left side that may be substituted out, that maybe we could get rid of? There's two ways to attack these. This problem, there's two correct ways to solve this. And one is not necessarily better than the other, but the worst thing you can do is nothing, okay? The worst thing you can do is stare at it. So sub something out, factor something, or just get rid of one of the squared things. What do you want to get rid of? Any ideas? Thoughts?
The negative sine of x.
Okay. They won't like cancel the way that you might think, but we could factor it out if you like. It's an option.
Let's try it out.
Okay, let's try it out. Now, I will say that this morning we took it a different direction, and that was okay. It wasn't. This isn't a problem. So what I did was I factored out a sine of x. Does what's in the parentheses look like it's possible that I could get that from something over here? Maybe instead of writing this, I should write sine squared of x plus cosine squared of x equals 1. Do any of these look like they're kind of close to that? So let's make sure that we have this. I'm going to use 3 different colors. Tangent squared of x plus 1 equals secant squared of x. Does the blue, the black, or the red look like it would maybe help us with this underlined green that I just underlined in green? Does the blue, the black, or the red seem like it would help us? Yes, thoughts? Maybe the blue one. I agree. So if we rearrange the blue one, if we were to rearrange the blue one, we would have, let's see, if we subtracted 1 here, we'd have cosine squared of x minus 1. We also have the sine squared of x here we don't really want. And that's going to equal 0 because we subtracted the 1, right? So would it be true that cosine squared of x minus 1 is equal to negative sine squared of x? Is that true? It is true. So we're going to put negative sine squared of x here, and we're going to put sine of x here, and we're now going to have negative sine to the third of x, and we're done. Very good. So some sort of manipulation of the blue, black, and red equations, the golden Pythagorean identities, are what we want to do here. So if you go down and you scroll down, there's 2 ways to go about this. I'm going to suggest another way to try this checkpoint. What I'm going to suggest you do is can you just get rid of this? Can you just substitute this out in the checkpoint? So why don't you pause the video and give this problem a try. Give this problem a try. So what we want to think about is, what does cosine squared of x equal? So cosine squared of x plus sine squared of x was 1. So cosine squared of x must be 1 minus sine squared of x. So now you know that that is what I want you to put there. And if you put that there, you'll probably find some cancellation. You might find that there's something a little odd about this. I'm going to try and see what happens. So I'm going to move on a little bit. So what was this going to be? 1 minus sine squared, is that correct? So I'm going to put 1 minus sine squared of x here. I'm going to leave cosecant of x. I don't really like that it's cosecant of x. What is cosecant of x kind of similar to? Cosecant of x is something, isn't it? 1 over sine. Do you think if we had all of these in sines, that would maybe be good?
Yeah, I think so.
That would potentially be good, yes. So we're going to change the black things. We're going to change those out to 1 over sine of x, because we know that that's what they are, right? And I have a feeling that that's going to be good for us, because now we have 1 minus sine squared of x, and now we're going to kind of distribute this, so to speak. Well, that means that we have the following. If we take this and we kind of go all the way up here, we now have 1 over sine of x, right, minus sine of x, because one of these canceled, 1 sine of x canceled, minus 1 over sine of x. And that will cancel that. And that's our final answer. You've now simplified it. When they say simplify, what they mean is get it down to one term, potentially, or get it down to one trig function, right? One of those two options, I guess, would be probably acceptable. It's not always crystal clear, but I think it's sort of clear, you know? It's somewhat clear what you need to do. Get it down to one trig function, or get it down to one term. Do you have any questions on that? If it's all right, we'll move to the next part. The next part is going to be a different type of example. Then we're going to combine those together on the third example. So we do one type, then we do another type. Look at these, guys. Let's say this was x squared minus 1. Let's say this was 4x squared plus x minus 3. Would you be in good shape if the purple were the questions I was asking you? Would you be in good shape if I was asking you the purple?
Yeah, probably.
Yeah, you'd be in great shape, right? You'd be doing great. That's kind of what I'm asking you. But the x is actually going to be a secant of x. And the x here is going to be a tangent of x. So the purple is not the real answer. It's the fake answer. The real answer is down here. But why don't we use the purple to get there? And we won't always use the purple. Sometimes we're going to go straight to the red eventually. But for today, the purple tells us what? Go ahead, you can just shout it out. X plus 1, x minus 1. Nice, nice, nice. This one, you got to make a snowflake if you were taught here, but for me, I just go like this. I got the 4x, and I think I got the 3x. And then if I subtracted 3 and added 4, that would be what it would be. Yeah? That look good to you? So the real answers are going to be this, but not x. What instead of x? Secant of x plus 1. Secant of x minus 1. And the real answer here? 4 tangent of x minus 3. Tangent of x plus 1. Do you see the similarities? Quite a striking similarity, if I may say. A striking similarity to the purple. The real answer's in red. We won't always do the purple part. We'll just go to the red eventually. But when you can see it, you know, the intermediate step, it's not bad. It's not bad. It's a little bit tricky if you don't see that. So why don't you try the checkpoint, which is right here. So I would encourage you to pause the video and give these two problems a try. Feel free to scroll back if you need to. We're going to pause the video and give these two problems a try. Good luck. We'll see you in a minute. All right, so hopefully it's going well for you at home. I'm just going to make a suggestion. If you are a little confused, you could always think of this as 1 minus x squared. And you could always think of this as 2x squared minus 7x plus 6. And perhaps if you knew how to factor those here, you'd feel pretty comfortable getting the actual answer and putting that beneath the red line. So 1 minus x squared. So this must be, I think, 1 plus cosine of x, 1 minus cosine of x. Okay, so there's that one. That's it. It's done. And then part B, a little weirder. Let's try to factor it with the purple part for starters. So 2x and x. I think it's going to be 3 and 2. Let's see, 3 here and 2 here. Subtract, subtract. That looks good to me. So the real answer becomes 2. What's the trig function? Cosecant, right, of theta minus 3. That's okay. And then cosecant of theta minus 2. And this is our actual answer. Sorry for that line running down the middle there. And that's what you need to do. All right, so we're going to try one more, and then we might be able to wrap, because we want to kind of keep the video, you know, a reasonable length. So the next problem is combining both types. So it's like, oop, did I get there? Let's see. Yep. Okay, look at it. Okay, what's different about this one? Can you factor that? No. What's the problem? Yeah, 2 different trig functions. So we have the green trig function and we have the red trig function. Now my question to you, okay, happy holidays to you guys. The green trig function, is that one going to be easier to swap out or the red one? Which one's easier to swap out? Think of your favorite identity in the whole world. What's your favorite identity, Max, in the whole world?
Sine squared x plus cosine squared x.
Right answer, right answer. The answer came sine squared x plus cosine squared x equals 1. And that is an awesome identity, okay? So sine squared x plus cosine squared x equals 1. If we love this identity, I mean, these are all squareds, right? So this is the guy that's got to go. The one that is squared is the easiest one to replace. It's just like the no-brainer, let's try it. It may sometimes lead to a dead end, but 90% of the time or more, it will lead to something really good, okay? So cosecant squared of x is 1 plus cotangent of x, if I'm not mistaken. 1 plus cotangent of x squared. And then this minus cotangent of x and this minus 3 are still just chilling. Thoughts on this? Well, now we have the 1 and the 3 that can combine. So we end up with cotangent squared of x minus cotangent of x minus 2. Right? Yeah, we could just take this 1 and 3. And now actually we could factor this into something. So we combined 2 things. The green was from example 2, the first example we did. And the purple, or what we're doing now, is from example 3, what we did just a moment ago. So condensing those 2 options into one. There's not a lot of space here, but I'll try to put cotangent of x and cotangent of x. Minus 2 plus 1 is how that would factor. It's done. That's it. So that was a 2-step problem. We had the stuff we did in example 2 and the stuff we did in example 3 mixed into one problem. We had to simplify it into one trig function, then factor it. We factor it as if it's not trig. We just pretend it's not trig. Okay, so try this checkpoint problem. Pause the video, give this a try. I'll put up the answer in just a moment. So just pause it right now. You don't want to see the answer. That'd be bad. So pause it now and give this problem a try. All right, and there you have it, friends at home. So I hope this was really clear and good. I'll see you guys in the next video. Peace.